Hello, my name is Mika Järvinen. I come from Aalto University. I work as an associate professor there. The topic of this short lecture is to introduce wind power to you. And first, I will discuss the operation of a wind turbine, how it could be simply mathematically analyzed. This figure gives you different components of a wind turbine. I have also here a small-scale wind turbine that I use in teaching with the students at the university. First of all, we have a rotor here that is in this case we have 3 plates that are attached to the hub, and wind comes from here and makes this to rotate. Then there is this low speed shaft here. In this case we don't have gearbox, but normally we have gearbox, and then we have another axis that has generator coupled. In these modern turbines, well, this is not a really modern turbine, but here we can twist or pitch the plates so they match perfectly with the wind conditions and rotational speed. We can also turn this turbine towards the wind. This is a yaw system, and also in the big turbines we have many measurement systems in place that makes the secure the efficient operation. And of course then this is connected to the transmission system and so on. How to calculate the power that you get from this? When this rotates, it defines a flow area. This is the A symbol in the equations. And first we need to calculate the mass flow rate that passes through the rotor. So this is simply the density of the incoming air times the area defined by this circle, and then times the free velocity of the wind. This is the mass flow rate, and each kilogram of air that brings in kinetic energy. So this is simply half times the wind power to 2, and the product of these, so mass flow rate times the specific kinetic energy, gives us the kinetic energy in the wind. But these turbines, they are not able to utilize full power, only a fraction A of that kinetic energy. And this parameter A is called power coefficient. And this figure here shows an example of a commercial turbine. And you can see that at maximum this turbine here shown gives 3 megawatts of power, and the maximum power coefficient is around 0.5. And you can calculate all other points as a function of velocity using this kind of measured curves for the turbines. And then time for some math. And what I did, I used Excel to calculate this kind of a curve. And the figure on the right gives the calculated power for a power coefficient A equal to 0.5 and free wind velocity 10 meters per second. And this is the curve. It gives the rated power as a function of rotor diameter. This figure also tells you an idea that what is the history behind the development. And for example, when I started my doctoral studies in 1998, we had 1 megawatt turbines. That was the maximum. Then 10 years after that, it was already 3 megawatt. And the prediction is that 2022-23 we will have already turbines that has power of 15 to 16 megawatts in serial production. And when we have these large turbines, then the size is already 250-260 meters of the rotor. So it means that this diameter is 250 meters, and the hub height from the ground is 250 meters roughly. So these are mainly purposed or aimed for offshore use, so operating on the sea. And just lasting theoretical maximum for these turbines is 0.593, and this is called Pet's limit, but this is something that I'm not going to details of that. You need to come to the university to study this further. Thank you for listening again. If there are any questions, please send me email. Happy to answer those if you have any. Thank you.